All right, welcome back. We are now on the bottom of page number 56. So we're on the bottom of page number 56. Just going to move my little icon up here back. Okay, so we are talking about isotopes. Now, I like to pick apart words. The prefix iso means something is the same, but not everything's the same, right? An isosceles triangle does not have everything the same. It does not have all equal sides. An isosceles triangle only has 2 equal sides, not 3. That's what makes it isosceles. So in an isotope, something is the same, but not everything. So atoms of the same element, right, have the same number of protons in the atomic number, right, because the number of protons is the identity of the element. No two elements have the same number of protons, but they have a different mass number due to the different number of neutrons in the nucleus. Quick review, the protons have a mass of 1 atomic mass unit. Neutrons also have a mass of 1 atomic mass unit. The proton is positive, the neutrons are neutral. So when you have a different number of neutrons, more or less, it's going to affect the mass of the element. So we have what's called an isotope notation. So I have carbon-14, where carbon is the name of the element and 14 is now the mass. So whenever you see a dash and a number, that number is going to be the mass. And you're going to use that number no matter what the periodic table says. So carbon-14 is now our symbol with our mass. And then we have a third way of writing an isotope or an element now. We have carbon with the 14 on the top, and that's still going to be the mass, and we still have the symbol. And now what we're not given here, though, is the atomic number, which is 6, but I can get that from the periodic table. So this carbon has 6 protons because it has the atomic number of 6, but this carbon has a mass of 14. So it's a little bit heftier. So there's a different amount of neutrons, and then that is why the mass is 14 and not 12, which is what it says on the periodic table. So some examples of some isotopes, right? We have 3 isotopes of carbon. Carbon 12, 13, and 14. Remember, whatever comes after that dash is the mass number. So let's examine the atomic number, mass number, protons, and neutrons for these 3 isotopes of carbon. So the atomic number is 6. That's the identity of carbon. That's what makes carbon carbon. And I got the atomic number from the periodic table. My mass number is 12. So where did I get that? The dash off of the isotope notation at the top. So I have a mass of 12, a mass of 13, and a mass of 14. Right? I have from lower mass to increasing mass. The number of protons is equal to the atomic number, which is 6, right? Because the protons is what equals the identity. No 2 elements have the same atomic number. No 2 elements have the same number of protons. So now protons plus neutrons equal mass. Let me just jot that down. So protons plus neutrons, right? P for positive and neutrons is equal to the mass number. So in order to get the neutrons, I take the mass minus the atomic number. So 12 minus 6 is 6. So carbon 12 has 6 neutrons. Carbon 13 has 7 neutrons. And carbon 14 has 8 neutrons. So carbon 14 has the most neutrons. It's still carbon. They have the same, all these carbons have the same physical and chemical properties. This carbon 14 is used for radioactive dating. So radioactive dating carbon, and not because it likes to go out with other carbons and take them out to dinner. It's a nuclear isotope. And in our next lesson, in our next set of notes, we're going to learn how to calculate the average atomic mass, which is the different isotopes. So if I go back one slide, then the average mass of carbon on the periodic table is 12.011. Why isn't it exactly 12? Well, because every carbon sample has a little bit of carbon 12, a little bit of carbon 13. It's actually mostly carbon 12 because look at how close that number is to 12. So that's what we're going to learn how to do. We're going to learn how to calculate that in our next set of notes.